Guys, welcome back to my channel. So I'm making this video after a long time because I was busy in my internships and college stuffs. So let's start this video by this problem: maximize distance to closest person. And this is a pretty nice problem which interviewers nowadays are liking. They are like asking these kind of problems very frequently. So this is not too easy, not too hard, and if you are able to solve this problem, it means you have a good understanding of arrays and you're sharp-minded, definitely. So let's understand this problem. You are given an array representing a row of seats where seats of I equals to 1 represent a person sitting on the ith seat, and seats of I equals to 0 represents that ith seat is empty. So basically you are given an array and each index represents a seat, and if the value at that index is 1, it means that seat is, on that seat someone is sitting. And if the value on that index is 0, it means that seat is empty. So now we have a friend named Alex, and Alex wants to sit in such a way so that the distance between Alex and the closest person to the Alex is maximized. So let's understand clearly what I mean to say by this example. So we are given with an array called seats, and the values are like 1, 0, 0, 0, 1, 0, 1. So at 0th index, you can see here it is 1. And if it is 1, someone is sitting at 0th index. Now at first index, the value is 0. So the first index is empty. The second index, the value is again 0. Now it is also empty. And similarly at third index it is 0, so it is empty. Now at fourth index the value is 1, and if the value is 1, someone is sitting at fourth index. Now again at fifth index the value is 0, and again at sixth index the value is 1, so someone is sitting at sixth index. Now we have to check whether where we should place Alex so that the distance is maximized, and then we have to return that distance. So let's check where Alex can sit. So let's start from back, and we can start from front also, but let's see from back side. So at sixth position someone else is sitting, so we cannot make Alex sit there. So let's start with the fifth index, because this is the first empty seat. So if Alex sit at fifth index, the closest person to Alex will be either 6 or either 4. Both of them are equally closest to Alex. So what will the maximum distance to the closest person of the Alex? So the index 6 is one step further from Alex, and the index 4 is one step further from Alex. So both of them have equal distance of one step. So the maximum distance between Alex and the closest person will be 1. Guess is very easy, because Alex is sitting at 5th index and someone else is at 4th and someone else is at 6th. So the closest person, both of them are closest person to Alex, and both of them have a difference of 1. So if Alex sits here, the maximum difference will be 1. But now let's check for other possibilities. Like this is the next empty seat we have, the index number 3. So if Alex sits here at index 3, what will be the closest? Who will be the closest person? First tell me that. So the fourth index person, the person sitting at fourth index will be closest. I guess you are getting this. The person sitting at fourth index will be closest because Alex is sitting at third index, and the next person is 0. 0 is farther from Alex as compared to 4. So the closest person is 4, and again the difference is only 1. So Alex just one step away. At fourth index someone else is sitting. So the farthest distance of the closest person is 1 again. Now let's check if Alex sits at second index. So if Alex is sitting at index number 2, who will be the closest person to Alex? So we can check from right. From right it is the fourth index person, and from left it is the first index person. Looking at that example, let's move forward and see the approach. But I will suggest you before watching the solution or my approach, just go and try this on your own. Definitely you will be able to solve it. And if you are not able to solve it, then it's totally fine. Let's watch my approach and see how we can tackle these kind of problems. So first of all, let's understand with this basic and very important case that suppose two persons are sitting, like this is the first person sitting and occupied a seat, and this is the another person occupied a seat. Now if we want Alex to sit in between them, where I should place Alex to get the maximum distance with the closest person? So as far as I can see, I should place Alex in the middle of both of these persons, because if I just shift it towards any of them, then the shortest distance between the closest person, farthest distance between the closest person will be minimized. Like, see, if I shift Alex here, the distance will be minimized to this with this person. If I start moving it in left, and if I start moving it in right, the distance between the closest person with this is going to be minimized. So to get the maximum distance, I need to let Alex sit in the middle of this array, middle of this segment. So finally, what we need to find out, if anyone is sitting at these indexes, then they will be 1. So we need to find out the maximum difference between any two ones, like any two of these persons, and at last we will just make it half. Like here, the difference between these two persons is 6. 1, 2, 3, 4, 5, 6. So the difference is 6, and if we make it half, then the difference will be 3, which is the actual difference of the Alex and the closest person. So we just have to calculate the maximum difference between any two consecutive ones, and we just have to make it make it half to get the distance of the Alex with the closest person to the Alex. Now there is another edge case in this problem. Suppose someone is sitting here and these seats are already empty. Now the maximum distance between Alex and the closest person will be what? So in this case, there is only one closest person to Alex. Like, there is no one in the left, and there is only one person at the right. So the difference between the index of Alex and the right person will be the maximum distance between the closest person. In this case, we don't need to divide it by 2 like here. Like here we calculated the difference between these two occupied seats, and we just make it half to get the distance from Alex. But in this case, we don't need to make it half, because this is the actual distance of Alex and the closest person. So we just wanted the actual distance of closest person and Alex, and we want to maximize it. So we have to check this case also. If Alex can sit at the extreme left, or if Alex can sit at the extreme right. In both these edge cases, the distance between Alex and the closest person can be maximum. So let's go and try to write the code for this. The code will be very simple. Let me remove it first so that you won't be confused. So we just have to calculate the difference between any two ones. So let's keep track of the last one that we got. So we are keeping a last index, or you can say last occupied seat. Use the last seat where someone else was sitting. Make it -1. Let's initialize it with -1, the last index. And we for this case, for the second case, this person, the first person who is occupying a seat, we need to keep a track of this also. I will explain you later in this video why, how we are going to solve it. So let's keep the first person index, or you can say first person index. Make it 0 or -1. You can initialize it whatever you want. Now let's move forward in the loop. For int I equals to 0, I less than seats dot size. So guys, let's understand the approach once again. So we have to find out the maximum difference between any two occupied seat and make it half. So the first thing that I explained here, find out the max distance between any two occupied seats and make the distance to half, so that we can get the closest the difference between the closest person to the Alex. So for doing that, what steps we need to follow? So we need to check if the current index is not empty. Like suppose we are at this index. So if this is not empty, someone is sitting here. So we just have to check the previous last index where someone else was sitting, and then we can find out the difference. So for that, we can keep track of our last person's index, last occupied index. So for that thing, we are keeping the track of last person who is occupying a seat, the last index which is occupied. So if we are here, we can just check the last index and we can find out the difference and can make it out. So this is the step that I've written here. If the current index is not empty, then check the last index which was not empty and calculate the difference between them and make it out. And we have to repeat this process for every non-empty seats that we get. Like if we got any other block here and if that is not empty, then we have to check for that also. So we have to repeat this process for every non-empty seats. And the second edge case that I discussed here for calculating those edge cases, I have mentioned the steps. So if index can sit at the 0th index or at the last index. Like if this is empty, then Alex can sit here also. And if this is empty, Alex can sit here also. If Alex is sitting at the 0th index, then the distance between the Alex and the closest person will be the distance between the first occupied index, or you can say the first occupied index minus 0. The 0 is the distance, the position of Alex. So what will the difference? The first occupied index and the 0. And similarly for this, what will be the difference between Alex and the last occupied index? That will be n minus 1 minus last index. Like this is n minus this is the size. We just have to find out this difference. So how we can calculate it? We can subtract this from this, so we will get this area. So we just have to remove from n minus 1. We have to remove this part, and we will get our answer. So now we have to calculate maximum of all of them. So let's see how we can calculate it. Let's keep a global variable result, which is going to keep our answer. So initially it is going to be 0. So let's check if we got any last if we got our at this index, if we got that this is occupied, if this index is occupied, then we have to check our last index. So what we have exactly do, we have to include the difference of the current index, which is I, and the last occupied index, the last occupied seat, you can say yes, and then we have to make it half. So I explained you why we are making it half, because this is you can say the maximum difference that Alex can get with the closest person. Now we have to make our result. We have to update our result as maximum of result, because we want maximum, so we are updating our result with difference. But now we have to include our edge cases also. Like if it is to calculate edge case, we need to keep track of all the first occupied index. Like we need to calculate this person's index. How we can do that? And very easy. If our last occupied seat was initially set to 1, occupied seat was initially set to -1, Then if we got any occupied seat, it means that this is the first seat which is occupied. So we can update our first person index here to I. Means this is the first seat where someone is sitting. And at last we have to update our last occupied seat every time to I. Now we just have to we can calculate our edge case answer. Edge case answer will be what? First person index minus 0. We can say it's like maximum of the if Alex is sitting at 0th index, or if Alex is sitting at the last index, then what will be this? Seat dot size minus 1 minus the last occupied index, last occupied seat. So this is going to cover on of our edge cases, and we have to return maximum of our edge case and answer. Now let's see what we are getting as an output. I hope everything is fine here. Okay, this is not answer. This is result. We are using result here. So, okay. Now it should run fine. Let's see. Okay, there is a typo in the name of this function. Okay, now we are going to submit it. As you can see, everything is running fine. So it is accepted. So let me explain it once again. Let me explain the code. So what we have done, we have we just keep track of the last occupied seat, and if we got any occupied seat, then we just find out the difference between the current seat and the last occupied seat, and then we are dividing it by 2 to get the difference between the Alex and the closest person, and we are updating our result to get the maximum of it. And at last we are updating our last occupied index too, because this at this index someone is sitting, because this is 1. So this is going to be our last occupied seat every time. And if last occupied seat was initially set to 1 and we got our first person who is taking a seat, then we are just going to update our first person index, and we are using it to calculate our edge cases, and then we can just simply return our answer. So if you have any doubt, you can ask in comment. I tried my best to explain this problem. So please like, share and subscribe to my channel for more content like this. Bye bye, see you in the next video.